Okay, hello everyone. My name's Jennings. I'm VP of R&D at Push Security. I'm here today to talk to you about threat hunting in the browser. So, brief moment on how I came to this project. My background originally is very much red teaming, pen testing, offensive security research, and that sort of thing at MWR Labs, which then led into the detection and response space eventually in designing EDR and doing threat hunting research for Countercept, which is a managed detection and response service. And then eventually I got to Push, and I now focus on identity attacks and SaaS security research. So I kind of had to throw away almost everything I already knew from the endpoint and network attack eras to move into this space. That's what's led me onto this topic overall. So, quick agenda, what we're going to go through today. How do we get here is going to be the first question. Look at how the threat landscape has changed. And I'm going to sort of demonstrate some identity attacks. I could talk for hours about this particular topic, but it's important to set the scene for what comes later, so I'm going to give like a real quick run through and do some identity attack demos, and then look after that at why the browser is the new front line because of this. We'll look into the sort of basics of browser extensions and how you can use them for security use cases, for detection and response, and we'll have some demos of that too, and I'll show you the code and everything. So, first of all, how do we get here? I like to view things in eras. I got into the industry in the mid-2000s. That was definitely the network perimeter era. We were trying to bypass firewalls, get past the DMZs, attack external facing services, that kind of thing. Then we got quite good at defending that. We tightened it up. We made a good, strong network perimeter. And in the 2010s, eventually we pivoted, and it became the endpoint was the new perimeter. And we started attacking endpoints, getting malware running on endpoints through targeted phishing attacks. We'd have a memory resident implant running, talking out to a command and control server, and we'd laterally move around an internal network, that sort of thing. That's been the case for a long time. Obviously, that led to the creation of the EDR industry and so forth. In the 2020s, we've now entered the identity perimeter. So we've now moved to a case where technology has changed and some of the threats have changed, and identity attacks have become far more common. So, in terms of an infrastructure comparison point of view, grossly simplifying things here, but what I'm thinking about from a traditional perspective is something that looks like this. We have a traditional organization that has an internal network that has their desktops and laptops on it and internal servers. We then have a DMZ with servers that need to be internet facing, like maybe applications for customers, maybe a webmail server. And then we have roaming users connecting in via VPN, and endpoint attacks were based around compromising something on the inside and connecting out to a malicious C2 server. But a modern view of this, many organizations like Push ourselves, other smaller companies that have started, say, in the last 5 years, are very much just a fleet of endpoints connecting directly out to a whole bunch of applications, different SaaS applications. Maybe some of those things go via an IDP for SSO, maybe some of them are direct. And for larger organizations, they typically are both of these simultaneously at the moment. We've got enterprises that have gradually migrated a lot more to SaaS. In many cases, there'll be a whole bunch of shadow SaaS they don't know about that's been self-adopted by users. But they'll still have the legacy networks as well, so we tend to have this hybrid model. So that's what it looks like from an infrastructure point of view. So how's the threat landscape changed? Well, identity attacks, they're now the #1 attack. If you even looking at, say, a very endpoint-focused company like CrowdStrike, even they've said 80% of attacks involved identity and compromised credentials. Microsoft has said 10 times increase in identity attacks. And Verizon has said things like, stolen credentials were the #1 breach vector in like 80% of web attacks, and 1,000 credentials appear online each day. So they've already become the #1 threat. This is not like what's next. This is what's already happening. And we can see this in the frequency and impact of attacks as well. So like in terms of public breaches that we've seen, even just a couple of years ago, there weren't that many breaches happening in the public domain, at least, that kind of fit into this space. But we've seen a real increase in the number and the sort of severity of those, where in the last year, say, we've even seen huge identity providers themselves compromised, like Okta and Microsoft, through identity attacks. And then most recently, we've had the Snowflake account breaches that were have been dubbed potentially one of the biggest breaches in history, which was a pure and very simple identity attack. So this has already happened, and it's just snowballing from now. So one thing I like to think of in this space, and I didn't coin this phrase, but I've seen it used quite a lot now, and I quite like it, is that now attackers don't hack in, they log in. Now, there are a whole bunch of different types of identity attacks. I'm going to reference some stuff for further reading later, but I'm just going to consider a few simple ones right now. Modern variants of phishing, like attacker in the middle phishing, browser in the middle phishing, which we'll see shortly, and modern variants of info stealers, where typically speaking, they're both two different methods of stealing either credentials or cookies. And using those, if it's a single-factor account, then just the credentials alone is a valid account. You can then take over the account. If it's protected by MFA, you can steal the cookie instead. You can perform a session hijacking attack. You take over the account. And then for modern cred stuffing, you take the credentials you've got, and rather than there be one webmail endpoint and one VPN endpoint to try them against to see if they're valid, you've got 1,000 different SaaS applications out there to spray them against to see what drops out. Again, leading to account takeover. So, I'm going to skip ahead now and just show a few different identity attacks chained together. So we're going to see, first of all, I'm just going to use an example of attacker in the middle style phishing for initial access to an Okta account. Then I'm going to look at what persistence and lateral movement can look like in the identity space as well, because that's very, very different to traditional endpoint compromise. So to start out, I'm going to use a tool called EvilNoVNC here. And it's actually a browser in the middle technique, but it's just a subset of attacker in the middle. So what we're doing here is we're sitting between the victim and the real server, and we're proxying the connection in a way. Now, a browser in the middle technique does it through desktop sharing. So it uses, in this case, we're using EvilNoVNC. It uses VNC to proxy access to the attacker's browser. So in this case, we've got the victim on the left. They've already clicked a malicious link. You can see my lovely definitely-not-phishing.com domain there. On the attacker, on the right, we have the attacker. So I'm just going to switch from the EvilNoVNC server to the attacker's browser, and you'll see here how the mirroring goes. So the real browser is actually on the right. The victim's just looking at a rendering without realizing and interacting with it, which means the attacker can actually see everything mirrored. So we're emulating the victim, entering their credentials on the left. The attacker can watch it like the movies, like live on the right. So the victim enters their password. They're then prompted for MFA because they're talking to their real Okta tenant at this time. They just don't know they're remotely controlling the attacker's browser instead. So they then go to the Okta Verify app on their phone, enter their one-time password, and they're signed in. Now, at this point, if they weren't suspicious enough to not do this already, at this point, they're going to see their exact Okta tenant with all the apps in the right order as they'd expect to see them. So then, once they've actually logged in, they're probably going to be less suspicious than they were previously. And from an attacker's point of view, they now have their browser logged in for them. So you could try and do something a bit clever. I'm just going to do something very coarse here and say, thanks very much. I've got what I wanted. Let's cut them off now. Break the connection. Now my browser's logged in. I've hijacked their account. So this is like attacker in the middle techniques are essentially mainly geared around bypassing MFA, like adapting phishing for this. So at this point, I then need to think, well, what am I going to do with this? I've got access to Okta. Maybe they set up some Okta SWA logins, which is a glorified password manager. I can go and steal some passwords for some other apps. I can also just log into all the other apps and establish sessions with those too. But if I'm happy in the short term, I can tear this down. I can also see what else I've got access to. So I'll tear down the EvilNoVNC connection here, and I'll have some other data available to me. So I'll also have been keylogging that time. I can go and see what I've got from the keylogger, which is going to be the password I used and the one-time password. Now, of course, that password on its own is not going to get us back into Okta because of the MFA, but with modern cred stuffing, maybe that password's going to be used elsewhere, and we can try that too. But of course, the important bit in here is that we've got the cookies, and so that's how we were hijacking the session, and we can resume the session in another browser using those if we want. So that's like the first initial access point. So instead of like compromising an endpoint, and that be your first foothold into the network, you're generally compromising an account on an app. In this case, we compromise a core SSO account, but it could equally be an individual SaaS application that a user uses. So now we're going to look at post-exploitation, and this is really interesting in the identity attack era. From an endpoint perspective, you'd normally be wanting to have your malware running and set up some run keys, some scheduled tasks, like many different persistence vectors to make sure your malware continues to run, and then you'd want to laterally move to other systems. Here, we want to maintain access to the identities we've compromised and the applications we've compromised. So it's very different, and it's actually very simple. And from an incident responder's perspective, it's actually a nightmare. So let's say we're the attacker now, we've resumed our session in Okta here. The first thing I want to do is just establish as many sessions to different apps as possible. Then, even if they figure out I'm in their Okta app and they suspend the account or reset it or kill the session or whatever, I've already established sessions on all these downstream apps. So it's already one level of pain for the incident response to deal with. They've got to try and figure out how they kick me out of the other apps then. But also, I can go another step further and look for simple persistence vectors. So I've just gone and clicked to log into Shortcut here, which is it's a ticket management system, much like Jira. OK, there's API tokens. Very simple. I go and create an API key. Not every form of API is based on the admins only. There are many SaaS apps out there that have APIs for user levels. So I'm just a standard user there. I create an API key, and then that's it. I'm decoupled. From then on, as an attacker, I can come in by the API. I don't need Okta. I don't need anything else. They can reset all the passwords and the creds. I come back in that way. Incredibly simple. There are many other very simple techniques as well. I'll switch to Google Drive now. Let's say we've compromised a finance user. OK, I'm interested in the finance information. Let's just go and make a sharing link. I'll come back and access that whenever I want to access the data I'm interested in. Don't need their account anymore. Very simple, commonly used for legit purposes. People often aren't looking for these kind of things. And sharing links exist in lots of other platforms as well. It's not just file drives too. Now I'll pick a third app. OK, I'm accessing Expensify. It's a finance user. Maybe they're even a manager of this app. So let's go and see if there's a way to do it here. And here's where I'll use something called ghost logins. There are ways to set up separate authentication mechanisms. So the official way is a SAML login from Okta to this app. But I'm going to go and set up a secondary login and add my Gmail account. And if no one sees that, then I can just log in separately to this account with the Gmail account I control in future, while the victim continues to use their SAML SSO login without necessarily knowing that I've got another way of accessing the same account. And again, if you've been in IR before, you start thinking about this from a compromise perspective, just from a low-privileged user compromise, all the different ways someone can go and put their hooks in. So persistence is incredibly easy and incredibly powerful, but very difficult to deal with in this space. And I'll look briefly at lateral movement. I'm going to use a little bit more of a technical example here, which is a bit more unique to the identity space. I'm going to use an attack called SAML jacking. So in this case, we've compromised the finance user. They're not an Okta admin. They're not an AD admin, nothing like that. But maybe they're an application owner for a finance app like Expensify. So maybe they're actually an admin within Expensify. IT has come and set up the SSO for them, but they've got access to the SAML settings. Now, the way SAML works is that it redirects during the authentication process to your IDP as part of the SSO process. So we're going to look at how you abuse this to use it for malicious purposes rather than for good security purposes. This is set up currently to redirect to my Okta instance for SSO. In this case, I've got like a bug crowd Okta instance, so you can see the bug crowd Okta preview set up there. I'm going to go and replace that with a domain for my evil no VNC attacker in the middle server. And what that means is we turn this into a watering hole attack at this point. Every other user of Expensify who comes to this later, whether they come directly to Expensify or they access it through Okta, during the login process is going to get redirected to my phishing server. So if I go back here and I click Expensify again, first of all, I get to expensify.com. You can see that up there. I have to confirm my username, and then it redirects. At this point, even if you're a really security-conscious user, you're going to really not expect him to be phished at that point. So it acts as a really kind of stealthy lateral movement technique. So then you compromise some more users, and then you repeat the process. And this is kind of what a modern identity attack focused on compromising SaaS-native type organizations with IDPs and lots of apps looks like. We're not touching the endpoint. We're executing the same kind of phases. We're using new flavors of some old techniques, and we're using quite new techniques as well. It's a mix of things. And we can conduct it very quickly, and from an IR perspective, it's quite difficult to deal with. OK, so that's to set the scene. Now we want to look at why EDR is ill-equipped, because this is one question we often get. Well, why not use EDR for this? Well, there's nothing wrong with EDR. EDR is a great tool, but it was designed in response to the endpoint compromise era. And we're now in the identity attack era, so it's just a different tool. Identity attacks, they rarely rely on endpoint compromises. Info stealers are like the main area where you get a little bit of crossover. But otherwise, they either talk directly to applications and services out there, or they touch the browser. It's the main touch point with users is they touch the browser, but they don't go as far as the endpoint. EDR generally offers only very light visibility inside the browser because it operates at a different abstraction layer, effectively. It's an OS-level component that's giving you visibility of processes and network connections and files created and so forth, which is what it was designed to do, and it's very good at doing that. But it doesn't really, the browser itself is pretty opaque beyond that. It just sees the general metadata there, and you don't get that much visibility of what's going on. So, why is the browser the new front line? Well, I'm kind of going to repeat myself a little bit here, but from an attacks perspective, identity attacks often target users' browsers. If you think about traditional controls, generally we've got, EDR we've mentioned, but also email gateways, secure web proxies, and so forth. Email gateways, they see corporate email. Web proxies see network traffic. Whereas now we have new delivery vectors. It might not come via corporate email, it might come via personal email, it might come via Slack or Teams or LinkedIn or X or whatever the case is. There's lots of different delivery vectors. And maybe the connection's not going via a proxy. We've got remote workers moving all over the place. Like maybe they're not all getting routed through one central proxy. If you look even back at ransomware used to hit file shares. It would do an endpoint compromise, encrypt things on the endpoint, find accessible network shares, encrypt that as well. Now, often we see SaaS data extortion. It's the same kind of thing. Attacks have migrated this way too. From a technology perspective, it used to be that old applications, most of what happened was in the network stack. So if you had a proxy that was decrypting things, the browsers were fairly dumb. They were kind of passing back HTML with a little bit of JavaScript and rendering that many years ago. Now, modern web apps are effectively almost like downloadable, thick JavaScript applications that happen to execute in a browser and then sometimes talk to APIs. Everything's trending to the web. Like, think if you're a pen tester 15 years ago, how many thick clients were you looking at? Versus now. Everything keeps moving into the web space, so the technology keeps pushing people here too. And then from a control perspective as well, we see the equivalent of sandbox evasion in this space now, in the identity space with phishing and stuff. So we've got a lot of evasion techniques that target link detonation approaches. So they try to, if security researchers or tools are automatically analyzing things separately, they try to make that behave differently. So I'm going to give an example, just a couple of things from a blog post I wrote a while ago. Really, you only see the correct behavior if you see what's going on in the user's browser, because people are hosting phishing things using legitimate services like Cloudflare workers, and they're using Cloudflare Turnstile as bot detection to stop automated analysis tools actually even seeing the server properly. They're then using crypto and doing other bits to set certain headers to make sure the next phase doesn't execute unless those original phases have gone through with it. And all of this is done to try and make sure that things like URL scan and other tools out there don't see what's really going on. So it's the equivalent of typical VM detection and sandbox evasion techniques in the malware world for this. But the browser sees everything that actually occurs for the user. So coming back slightly to the EDR point, the browser versus EDR, at the network level, obviously EDR is more OS orientated, so you see things like DNS, you see things like TCP/IP metadata. But from within the browser, if you're looking there, you've got tab levels of visibility. You know what's going on in each different tab. It's not one sort of homogeneous chunk. And you've got full access to the decrypted HTTP level traffic because you're sitting at a different abstraction layer. From an events, you're not just getting generic OS events like you do in EDR. You're seeing everything the user does within the browser. You're seeing full user interaction tracing. Every click, every keystroke, every DOM change that occurs within a tab, you can see an instrument. You can inspect every layer. The EDR doesn't have that level of detail, obviously because it's not designed to. There are a few other differences, like from a privileged perspective, EDR tends to be, running as full system or root, at least at a core level. It might then have other child workers that run differently. In the browser, we tend to be running in this browser sandbox with fine-grained permissions because it's a more modern permission model. The other aspect is OS compatibility. There's a little bit of difference there. With EDR, you tend to be looking at platform-specific solutions. With the browser, things are pretty cross-platform. If you run something on Chrome, and then Chrome runs on multiple platforms, it should run on all those platforms. So it's reasonably cross-platform in that sense. Okay, so the other thing I've seen in this space generally is people saying, well, but aren't extensions bad? And I think the reason for this is looking in the past when browser extensions first came around, there were a set of traditional risks. And people weren't using them for corporate purposes, really. It was users self-adopting browser extensions, like ad blockers and other things. And often in this case, corporates had sort of set up application control solutions to control what exes could run on an endpoint, and then suddenly there was this new source of things that wasn't subject to that, and people started installing extensions. They didn't have visibility, so everyone was like, okay, people are installing all these browser extensions. They don't know what's going on. That could introduce risk. There's also a supply chain risk there, because sometimes old extensions that have already been deployed and used by lots of users get hijacked or bought by other parties, and they can then be transformed into something malicious. So I think traditionally, people tended to just have this view of extensions as being a bad thing, because people weren't using them for good security purposes, and they were just like a new risk that occurred one day. But from a modern perspective, a lot's happened with extensions since then as well. Extensions can be rolled out using managed deployments, like more effectively, really, even than typical agent deployment techniques. They auto-update just by default. Don't even have to figure out anything about updating them. It's just built in, a bit like mobile apps. You can use browser policies to lock them down further if you want to, too. And from an OS perspective, they actually run in a very locked-down sandbox at the OS level, which reduces the risk somewhat. Within the browser, they obviously do have a lot of access. But from a traditional OS security standpoint, the browser vendors obviously thought a lot about that, and they run quite locked down. So from my perspective, using browser extensions to solve security use cases is basically a big opportunity, and we can't really ignore it. So I'm going to jump into some examples of using them now. I can't teach how to use browser extensions or develop browser extensions, rather, in one short part of a talk. So this is like a 101 of a 101. But the most important concepts to understand are these three things. First of all, you have content scripts. If you make an extension, you can write JavaScript in a content script, and you can define if and when you want that JavaScript to run in a page. So you could make it so that only certain websites have your JavaScript run. You could make it so that your JavaScript runs on every website. Or you could make multiple different content scripts that run depending on what the circumstances are. So you can control a lot just by the power of JavaScript at that point. The only difference there is that there's a concept of a world. There's an isolated world, and there's a main world. So by default, your content scripts will run in an isolated container, which means they won't be interacted with by other extension content scripts, and the JavaScript running in the page itself won't have access to your JavaScript either, so they're kept isolated from that. If you don't want that to happen, if you want to actually be in a shared space, you can define to be in the main world instead. But that's just a concept that exists. By default, it's isolated. Then there's background scripts. These are much more like the equivalent of an agent. They run in the background at all times, and if you define them, you can basically real-time monitor lots of events in the browser. So you can intercept requests and responses, all the network things, and just lots of browser events. And the third aspect is communication, message passing. You can pass events between these things. So you can send messages from a background script to a content script in an individual tab, and the reverse direction as well. And that enables you to do more advanced things by combining the sort of pros and cons of both of them and making use of them through communication. So we're going to see examples of all of that today. So I've got an example of the communication there in code, just showing how the communication bit works. It's really simple. At the top, you can see me in a content script sending a message via the Chrome runtime, and that will automatically go to my extension, my background script in my extension, sorry. And then the bottom bit is me adding a listener for that particular message in the background script itself. So it's very easy to send data between them. OK, so now we'll move on to some demos. Basically, we're going to look at the power of browser extensions. I just want to give you an idea of the sorts of things you can do and why they're really powerful and useful. I'm going to split this into two phases. So I'm aware there'll be lots of people that are principally focused on endpoint security, endpoint attacks, network security, that kind of thing. So I'm going to give a couple of things to show you why, even in the endpoint era, browser extensions can be really useful. Then the bulk of it will move on phase two. I'm going to look more at the identity attack use cases. And in doing that, I'm going to relate it back to the previous identity attack demos I showed you. So the Okta compromise and some of the post-exploitation stuff, I'm going to show you how some of these use cases relate to that. And I want to do that from a perspective of trying to think imagine that attack that you saw earlier happened to me, how would this stuff help me detect it or respond to it or investigate it or something like that? So phase one, the endpoint use cases, we're going to look at extension enumeration and HTML smuggling detection. Then phase two, we'll look at these other things, tracking malicious links, auto-screenshotting, proactive monitoring of user security data, and preventing weak passwords. So first of all, enumerating extensions. We said before they've been seen as risks. A lot of people don't have very good visibility of them. Well, one thing an extension can do is view other extensions. And it's really that simple. If you ask for the right permissions, this is the code to do it. The only difficulty with this is something you would need to proactively run. So I've set this up in a way that uses alarms, which is almost like running a scheduled task. I have a periodic check. I run. I see what extensions are installed. I report them. This is something that runs from the background script if you ask for the right permissions. So let's just see what our extension looks like. So here I've got my extension. I'm just going to refresh it. And I've got that my dev tools on the right-hand side is my background script. So it's not in the page. We're looking at the JavaScript console for the background script on the right. So I refresh that. You can see it's a fresh load. It installs the alarm, and then it runs an initial periodic check, and it'll run that again at whatever interval you define, but it's just run that straight away. And you can see how it's output all these events from doing so. So I can go and have a look there and see, oh, actually, it's one example. The first example on the list is the push security extension that's installed, and then you can see all these other extensions that are installed. So I can enumerate the other ones and get information that way. So that's useful just from an endpoint security perspective. Then I'm going to look at another example I thought was a good one. HTML smuggling. A lot of people have been struggling with this because HTML smuggling is designed to get around network-based and proxy-based kind of filtering controls. So if people are trying to block certain types of content and executable content from getting into their network, HTML smuggling takes advantage of the fact that web apps are downloadable JavaScript applications now and causes a download to occur locally within the JavaScript without some kind of network request returning a file with a MIME type and all that. So the proxy won't see it. You have to have the correct sequence of things happening in the JavaScript for the file download to occur. So it's invisible to proxy solutions. That's the intention. But we're in the browser. We can monitor all file downloads. No matter where it comes from, whether it goes via our proxy or not, we can see that in the browser. And this is the code to do it. Very simple. So I've just got a test HTML smuggle here. So imagine someone's got a phishing email with this or something that's using HTML smuggling. I'm just going to show you quickly that you can see it is just some script to build up a file and download it. So I close that. I click this button. There's no network requests. It just downloads this .m file. But I see this in the browser. I see what was downloaded. I see where it's come from. I can stream the content as well if I want to. Very simple. Gives you visibility exactly where you want it, where you would miss it with a traditional network control. OK, so that's just a couple of random examples for the endpoint. Now I'm going to look more at the identity phase, and I'm going to think back to that identity attack demo before with the Okta compromise. Now, first thing, if you're investigating a compromise like that, you've got to find some way to contain the incident if you can. But you're also going to be thinking, who else has been attacked? Are they about to send some more links? How do I start getting ahead of this? So what are your options? You might say, OK, well, let's search our proxy to see if anyone else clicked the same link. And maybe let's search our email to see if we can find the link in any emails, even if a user didn't necessarily fall for it, didn't click it, so to try and find people that were potential victims that didn't end up victims. But if it's come through, IM, or personal email, social media, whatever, you're not going to see that. Even if they've accessed it but hasn't gone through your proxy, you're not going to see it. Or maybe they've used different links each time. How do you track malicious links? Well, in the browser, we have full access to the DOM and everything that happens and all the events and everything that the user interacts with. We can literally see when a link appears in a clickable link in the DOM, even if it's dynamically created. And if someone clicks it, we can see that event and track that as well. I've just got a couple of examples of code here. It's really quite simple. The second point to this before I demo it is we also see the rendering in the browser. Now, I said in the past, it was mostly HTML going back and forth and the browser mostly done rendering it. But these days, what you're seeing going back and forth in a proxy, even if you're decrypting all the traffic, is like you can't easily see what the user was seeing. It's too complicated. There's lots of JavaScript and things being rendered and APIs being called. So if you want to know what that looks like to a user, it's very difficult to see from a proxy. But from a browser, everything's already rendered at all times. Anytime we want to, we can just take a screenshot of the browser. That's part of the functionality. So I'm going to show you how powerful something like that can be. Now, if we're taking screenshots all the time, there's obviously big privacy implications as well. But I just want to show you from a power perspective, there's always a trade-off there. Let's say this is how this link got distributed. It was a form of social media. I've ChatGPT generated a LinkedIn page there with an instant messenger. I sent my link to my Okta tenant from before. OK, so I'm just going to refresh this. So let's pretend we first visited this page. OK, I haven't done anything. It's just there. I've received a message. We've already got the link observation event. We know the context around it, so we could track this as well. We'd be able to, if we had this data before, we'd be able to go and search and see where this came from, even if this is personal social media. Then, if I click it, we'll then see a link click event separately. And we get taken to my phishing page. So we've got two separate events. Whether or not they fell for it, we can see just the fact they got it sent, and we can see that they clicked it if they did. And we can also take screenshots. So when those events occurred, I was able to take a rendering of it. So I'm just going to take the contents of this screenshot and show you, look, we've got a full screenshot exactly as the user saw it. So from an IR perspective, OK, there's a privacy perspective, but it's super powerful, really, really powerful. So think about trying to do this with traditional solutions. They just don't match up. OK, next thing, monitoring security data. I showed you a few different things in post-exploitation. I showed you a bunch of different persistence mechanisms, and I showed you some lateral movement. I haven't got time to look at all of those things, so I just thought I'd pick one. Let's say the first one we looked at, we created an API key in Shortcut, right? So let's say we've investigated this first instance, and eventually we figured out what happened. We're like, oh, not only did they compromise this account, but they established a session on Shortcut, and then we find out they created an API key, and then we're panicking, going, where else have they done this? What other malicious API keys exist on Shortcut for our other 10,000 users? And then we look and we say, well, we don't have an integration with Shortcut. It's an application, but we don't have logs from it. Maybe it doesn't even log those events. Maybe the admins can't even see this data. And in Shortcut's example, legitimately, I don't think there is a way to see this data. I think only the user can see their own API keys. So how the hell do I get that information? I can't email 10,000 users and say, can you please check if there's any malicious API keys? But we can monitor this from the browser. We're in the user's context. Like, if we really want to, we can go and put some code in to go and check this and run a periodic check and get this information back. It's pretty simple. So I went and looked at what the call was that happens when you query this and just implemented it like this. It's just a test tenant ID. You change that tenant ID for whatever one you use. So this comes back to our periodic checks. Now, currently, there's no shortcut tokens. Now, I'm going to create this here just to show it. Now, we're not going to track when the API key is created, because that would only work if the user was doing it themselves. The context here is that we're expecting the session's already been stolen, and the attacker's done this from somewhere else, somewhere we don't have any visibility. So what I want to see is that it appears without the user having done it. So I'm just showing and creating it there, but realistically, we want to find that on behalf of the user that that's happened. And we're doing that through periodic checks. So rather than wait a minute or however long it took for it to run again, I'm just going to force run the thing that runs every minute. And there we go. We now see that, as well as the browser extensions, this Shortcut API tokens appeared down there. And we could be syncing that data as well. And that would be a way of us gaining visibility across this. So maybe we didn't have this feature already, but when we're responding to the incident, we're like, OK, we need to go and verify there are no other backdoors in Shortcut. How do we do it? Here's the JavaScript we're going to update in our browser extension to do so. It'd be very difficult to do it otherwise. And then I delete it to make sure you don't access it as well, even though it's a test tenant. OK, so that's pretty powerful too. Then maybe we can do some proactive steps as well. Like maybe we realize some of the passwords in use are a week, and yeah, we control them on Okta and we control them on Active Directory or whatever. We realize people are using weaker passwords for other systems we don't have control of. But we see what they do in the browser, and we can interact with those things. We can literally observe as and when someone enters a password and interact in some way. It's as simple as this. So let's say we want to know when someone uses a weak password for any platform. and give them a warning to let them know that that's happening, to guide them to pick something else, we can do that. So let's just say login page, I go and put in password, and we can live pop up on the side there and fire an event to do that. So that's a proactive step we can take. So hopefully that's given you an idea of, one, how powerful browser extensions are as a security tool, and two, in particular, how important they are in the identity attack era. They're useful in the endpoint era too, but they're particularly important in the identity attack era. One other example that I don't have a demo for, but just to think ahead, just think about all the things you've seen here. I showed weak password detection there because it's easy. But you could try and prevent phishing as well. Stop people using passwords from one site and another. You need to keep it's more complicated. You need to keep track of that, but that's something we do ourselves. You can stop passwords. So it's just a very powerful tool. You can do it with weak passwords. You can interact at any point, and you can customize this. If you're an organization, writing your own code for an extension, you can do whatever you want, whatever the use cases are. So, the one other thing I've not spoken about, but it's worth considering if you want to explore these techniques yourselves, is collecting events. I've been showing you the events appearing in the JavaScript console, but obviously they're not useful locally. So I just want to talk through briefly the options, just so if you want to experiment with this, what your options are. The obvious option generally is HTTP comms. You're running JavaScript in a browser. You have the ability to talk to other endpoints. So you have a webhook for your SIM, for your Slack channel, whatever, you send the events there. It's really easy to do. So where I had a common function that was just logging things to the console, you would just put something to send it. Where it gets slightly more difficult, if you want to try out this yourself as a blue team, is obviously if you want to securely identify where the event came from, that's a little more challenging, because you then need some kind of identifier per browser and so forth. But in principle, it's very easy to send events. The other thing is, if you already have log collectors on endpoints collecting, say, Windows event logs, this is an interesting one, because if you've got that set up, you've probably got something that already does uniquely identify the endpoint, at least, that a message came from. It's probably already synced into your SIM. Things like Chrome have something called native messaging, put the link there. You can send messages to native binaries that listen for them, basically, from the browser. So you can make a tiny little binary, like a little .NET app, a little Python script, whatever, that listens for these messages and just writes them to the event log. And then you configure your EDR or your log collector, like WinLogB or whatever you use, to pick up those events. And then they would be automatically sent to your SIM along with everything else. So if you've already got a setup like that and you want to experiment with these kind of techniques, that's probably a really easy way for you to try this out and collect events already. So that's another option. Okay, so I just want to revisit this slide from before. I'm looking at things in eras: network perimeter, endpoint perimeter, identity perimeter. There's more than one control that's existed in these points, but if I look back and say, what's the primary thing, is firewalls and network segmentation were the key things from the network perimeter age. EDR was the key control for the endpoint perimeter age, and I think now in the identity perimeter age, browser extensions are going to be the most important component. The same way there's a million different agents for doing different things on the endpoint, both for security purposes and more general IT purposes. I think this is the way we're going to move. It's the natural evolution that's going to occur, because they're just in a position that's so powerful for achieving so many things. I've given a taster of things you could do today, but there's so much more you can do, and they're so valuable from a security perspective. Okay, so to conclude, identity attacks are the new normal. Browser extensions give us unique capabilities, though, for improving detection and response, both for endpoint attacks, but particularly for identity attacks. And the other consideration is, if you're an advanced blue team, maybe consider adding extensions to your tool set. Or if you just want to learn more about this, just have a play around with it. It's easier than writing your own EDR. You can try out some of these techniques yourself. So the stuff I showed you today, that little test extension with all those things, I've chucked that on GitHub there if you want to check it out. So it's effectively a very, very simple browser extension that's got a few things ready for playing with. And being JavaScript and being in the browser, it's pretty quick to get going with testing stuff for your own purposes. So even if it's just from a learning perspective, give it a go, run it locally, have a play around and learn how you can use these things. One other point before I conclude. I said at the beginning when I was talking about identity attacks that I could talk for hours about them, and I was just giving a taster to set up why I think the browser is so important. I released this over a year ago. Actually, I gave a whole talk effectively about how I created this at last 44Con. But I released a SAS attack matrix, which is basically kind of inspired around like the MITRE ATT&CK framework, but I looked from the perspective of how do you compromise an organization without touching the endpoint. A SAS native organization, no infrastructure, really secure endpoints. What do you do? This is what I came up with. I've been kind of maintaining it since then, and I've done lots of other blog posts around attacks in this area. So if you're more interested in the identity attack space in general, then please go check out that project and see any of the other talks or blog posts or webinars, whatever I've done related to it. But that's another really useful resource in this space. But that's it otherwise. Any questions?